continue the solving DS problems. This is the second part of DS tutorial. So let's consider other problems just quickly. Okay, in question number 5, we have to find prefix of this operation, but actually this is a little bit different because first we have to construct the tree and then do prefix. So constructing tree is relatively easy. For example, you choose this as your as the root, okay, and you consider this as a left child and this as a right child, okay. So let me write here. Okay, I'm going to construct only 3, okay. So in the left part we have what? This a plus b minus c multiplied d, okay. In the right child we have what? E power f, this is in brackets, divided g minus h, okay. So now you consider this separately. You set minus to be to your root of this subclass, and what we have left part, right part. In the left part you have a plus b, and right part you have c multiplied d. Here you set this division as your root of this subclass and set this as left, and this is right child. It's going to be this, and it's going to be g minus h. And then this is pretty easy. You set a as a root of this subclass, and right child is a, left child is a, right child is b. In this case, it's going to be c and d, okay. I have a shortage of time. Now, after 20 minutes, we're going to start our offline EM tutorial. So that's why I have to keep it short a little bit. So in this case, what we have is this, we have set it to be our root, okay, parent, and this is the left child, this is the right child. So E and F, I just forgot these circles, okay. So now this is minus, this is a root, this is a parent, G is a left child, H is a right child. So what does it mean prefix? You have to find prefix of this operation. To find prefix, you have to do pre-order traverse of this tree, okay. Okay, so let's do traverse. Pre-order traverse, what does it mean? I think you know pre-order traverse. Just let's leave it for you. Pre-order traverse means you firstly print node itself, then you go for left child and right child, okay. You print first node itself, then it's a left and right child. So I hope you'll successfully solve it, okay. It's pretty easy. Just look professors let you know. Pre-order traverse or post-order traverse is easy. For example, if you ask you to find postfix, what you do post-order, right? Let me write this. If you ask you to find prefix, okay, I have already written pre-order. But if you ask you to find infix, okay, infix, you have to do in order traverse. Okay, let's consider question number, this was question number 5, and let's consider question number 6 quickly. Here, okay, here you have to do these following operations, okay. Let's consider stack is empty, stack 1. Okay, we are given stack 1 and stack 2, and you are asked to do what? And you are asked to implement Q using 2 stacks, okay? So implementation is already given, so no worry, just have to do these operations. So in the first operation, you enqueue 5, and that means when you call this function, it push value to stack 1. So 5 to stack 1. And then what do you do? And then you enqueue Q6, you call this one, that means S1 push 6. And the same is 7. So now it's a DQ. DQ, you just have to look here. It says if stack 2 is empty, then enters this block. Is stack 2 is empty? Yes, empty. Okay, enter this block, check this. If stack 1 is empty, is it empty? Not empty, okay? It's not empty, right? So you come here. While stack 1 is not empty, okay, until, okay, and it means until stack 1 is not empty, pop value at stack, pop values and assign them to stack 2, okay? Okay, let's start popping and pushing. We are in loop. We are in loop. So loop while stack 1 is not empty. So pop from stack 1 and push, I mean, values assigned here and push to stack 2 well, okay? So just sorry for noise. Okay, let's consider it. So there's 7, initially it's 7, S1 is not, initially stack 1 is not empty. And when you call pop function, there is 5, 6, 7. 7 is returned. Stack is now 5, 6, and well is 7. You assign this well to stack 2, and now stack 2 was initially empty, and now it's 7, okay? In iteration 2, stack 2, I mean, this stack is not empty, and stack 1 is not empty, right? Not empty. So you pop the value from top, 6, value will be 6, and now stack 1 will be 5, and push this value to stack 2. Stack 2 was 7, and now you push it, it will be this one. And then stack 2, is this empty? Not empty, right? Not empty. So what do? You initially had 5, you pop it, assign to well is 5. So now you have stack 1 is empty stack, and you push it to stack 2. Stack 2 actually was this, okay? 7, 6, you push 5, and it becomes this one, right? So now in iteration 4, stack 1 is empty. So loop execution is done. Okay, loop execution is done. So now we are here. We have to pop value from stack 2. Okay, so stack 2 was what? Stack 2 was 7, 6, 5. Pop value. Okay, just get rid of it. That means now we have, let's say, 7, 6, right? 5 is removed. Okay, so now this is a stack 2. So this DQ is done. You see, for DQ, you have done so many operations. This is just a DQ, right? This is just DQ, okay? So now you are here, you have the enqueue function calls this, and you should, what? You should push 16 to stack 1. So after DQ, stack 1 is what? Stack 1 is empty. So let's write here. So now, actually, stack 1 is empty. Stack 2 is 7, 6. So now you enqueue 16 to stack 1. So finally you have stack 1, 16, excuse me, it's too big, right? Stack 1, and stack 2 is going to be 7, 6, okay? So let's briefly discuss question number 7 and 8. We have really shortage of time. In 7th, you see, this code given, you have to find out which operation this code does. And actually see, let's analyze this function, okay? Actually, okay, say stack is created, okay? See, stack is created as. So if Q is not empty, this while loop is executed. So imagine that, okay, problem number 7, we have Q and it has values, for example, 1, 2, 3, 4. Okay, and we have right now, this is Q, right? We are inside this function, okay? We are inside this function, okay? Inside this function. Q and stack is empty, right? We have what's that? DQ an item from Q and push it to DQ item to stack. That means, remember, this is front, this is rear, right? In Q, you DQ, you delete items from front. That means here DQ element from Q, remove element from Q and assign it to stack, okay? And you have to do it until Q is empty, right? See, initially 1, 1, 2, 3, 4. This is Q. Stack is empty. So we DQ from Q, we delete from front, right? Front deleted from right now is 2. Here, front is here, right? So 1 is deleted and it's put here. Stack has 1. So in the second case, so now we have empty, index 0. Okay, let's say index 0, 1, 2, 3. At index 0, there's no element because front is right now at index 1, yeah. Front is here, right? It's incremented. There's 3, 4, rear is here. So we delete, actually stack is right now has 1 element. So now, again, we DQ, we delete front, we increment front, yeah? Increment front is right, then it's going to be at index 2. So the value at index 1 is deleted and put to stack, okay? So now, again, we do it until Q is empty, okay? Q is not empty, Q still has 2 elements. One, it indexes, front is here, right? Array is here, stack has 1 and 2. So we delete, okay, again we DQ, Q is not empty, right? Q is not empty. This is true, this is true. That means not empty, it's not empty, it's true. So we DQ, we get, this, the value at front, put it stack and increment front, okay? So now front will be, R will be at index 3, So our Q will be what? Index 0, 1, 2, 3. At index 3, we're going to have F, right now it's F, F equals to R, it's 4. As I've told you, part 1, F equals R only when there's only 1 element left, okay? When we delete from Q, when there's only 1 element left, we set F and R to -1, okay? This is the next step. So right now, stack is what? 1, 2, 3, it's a stack. So fourth, it's not empty right now, it's not empty, so we DQ. So it's 4, it's deleted. So F and R were 3. So now F and R are going to be what? -1. So this 4 is put into stack 1, 2, 3, 4. So that's it. In fifth operation, Q is empty, right? No element. The index is no element. So while loop terminates. Yeah, this condition is false. So stop here, right? Okay. So we're done. So now we came here. That means after this while loop, there's also while loop, and now we do what? We have stack, right? To these elements. Q is empty, right? Q is empty. So now we pop elements from stack and put it to Q until S is not empty. Okay. Okay. Initially, what? Initially, it was 1, 2, 3, 3, 4. As you know, in stack we do operations. When we pop, we get rid of the top element. So now top is 4, and you put it in Q. We put it in the very first, okay? So now this is front and this is rear. So when you add element, in Q, so you add +1, or let's say increment, you increment rear, okay? So now rear is 0. Okay, stack has 1, 2, 3. It's not empty. So top is 3. We pop it and put it to Q. Where do we put it? We put here, right? It's going to be 3. Front is not changed. Rear is changed. Rear was initially at index 0 plus 1. You increment it. So rear is now at index 1. Okay. Again, now our stack is not empty. It has 1 and 2. And we get rid of this top element. Yeah, it's top actually. And put it into Q. Where do we put it? Actually, it was 4, 3. It's a front. Initially, it was rear, but you put 2 here. So rear is incremented. So rear is now here. Okay. At index, it's going to be 2, right? So now stack has 1 element. It's a top. I have to get rid of it and put it to Q. 4, 3, 2. Actually, it's front. Front is not changed because we don't delete any element, but there is rear. But when you put 1 here, you update rear, increment it, and it will become at index 3, right? So now, as you see, stack is empty. So second while loop terminates. And this was last. I mean, in the picture you can't see, but after this while loop, there's nothing, and function returns Q. Function returns value of Q. So initially, when Q entered, it was like this one. It's exactly right. Actually, when Q entered this function, Q had values 1. What kind of values it had? It had values 1, 2, 3, 4. But after the execution, the values of Q are right here. Initially, let's say initially, and finally, it has values 4, 3, 2, 1. As you can see, the values are reversed. Values are reversed. So let's choose the correct function of this, correct operation of this function. So it's D, right? This function, just reverses the Q, okay? D is correct. It's reverse. Function reverses. The question was to identify the operation, what kind of operation does this function do, and this function reverses, okay? So finally, let's quickly analyze the problem number 8. Okay, we are given this linked list, right? We are given a linked list. So what's that here? See, you have temp variable, temp node, and its values are, okay, let's say temp is written here, okay? It's the name of this node temp, and values is 0, 0, and it points to null. This means it points to null, okay? This cross sign. So you look, okay, see, it's a PTR is head, so PTR is head. So you loop, see, PTR next, what does it mean? You assign PTR next node of initial PTR. Assigned to next until data of PTR is 7. For example, initially PTR is 26, okay? I mean this node, its value is 26. It's not equal to 7, so we go here, yeah. So now PTR is 38. Its value is not, I mean this node PTR, okay. Its value is not 7. We go to the next node, and this now PTR, and its value is 7. So this while loop terminates, and we set this PTR next pointer to 10. So PTR is now this one. So we update this next pointer to this one, okay? So this part of the linked list is ignored. So now 7 doesn't point to next 7, points to temp, okay? See, ptr next is 10. So I will redraw the new linked list. This is temp, okay. This is 26. This is 38. This is 7. So this is 0, 0, temp has 0, 0. So the question is, how many elements have linked list after these operations? As you can see, initially nodes were 5 initially, but now it's 4. So the answer is 4. So guys, this is the end of our tutorial. Hopefully you like it. Please subscribe to our channel, follow us, be active, write your questions. And anyway, this was the end, but we're always here to help you. If you have any kind of questions, please feel free to ask. Part 2 was a little bit fast, but anyway, this is pretty straightforward. I hope you will have no problems while analyzing these problems. And in the video description, you can find the link to the source code, okay? Source code where we implemented queue and stack. You can find implementation of both circular queue and linear queue, and also you can find implementation of stack using array and linked list. Thank you very much. See you soon in our next tutorial.